Now, what if we just want approximate solutions to trigonometric equations? So we're going to use a graphing utility like a graphing calculator or computer software to approximate the solutions to 3 decimal places of this equation. We're going to find all the solutions in the interval from 0 to 2 pi. So our equation is 2 times the tangent of 2x plus 4 equals 0. So it's like this function, 2 times the tangent of 2x plus 4, is what we want zeros for. We're looking for the zeros of that function. Here's how you could do it with a graphing calculator. First, let me make sure I'm in radians mode, because we do want solutions in radians. Now, let me ask the calculator to graph this function that we want zeros of. 2 times the tangent of 2x plus 4. Now, the places where that's equal to 0 correspond to the x-intercepts on the graph. I can see a whole bunch of them, but we only want the ones between 0 and 2 pi. If it helps you to focus in on just those, we can change the window so that it just shows that interval, or maybe a little bit outside it, like maybe from negative 0.1 to, let's say 2 pi plus 0.1. So we have room to see if there's anything right at the ends of that interval. So it looks like we have 4 x-intercepts in that interval, 4 solutions to that equation that are somewhere between 0 and 2 pi. Now let's ask the calculator to help us find them. Now this one here looks like it's right around 1. Can't tell if it's 1 exactly or just really close to 1, but somewhere around 1. So I'm going to go to the calc menu and ask it to find a 0. It's going to ask me for a left bound, and I can either use the arrow buttons to move over to a point that I know is somewhere to the left of that x-intercept. Right now I've got it at a point where x is 0.93455.085, or I can just type in a number that I know is a little bit less than where the x-intercept is. So I could just type in a number that's a little less than 1, like 0.9. Now my right bound has to be somewhere over to the right of that x-intercept. Again, I could use the arrow buttons to move over there, or I could just type in a number that I know is a little bit bigger than what this is. Here, I'll just leave it here. I'll hit enter. Now it's asking me if I want it to guess. I do, so I hit enter again. And it comes up with 1.017222. So to 3 decimal places, that's 1.017. Now let's find the others. This one is, well, let's go back to the calc menu. Tell it we want a 0, but this time for a left bound, we want a point that's a little bit to the left of this x-intercept. And for a right bound, we want to be a little to the right of that x-intercept. And when I ask it to guess, it comes up with 2.588. Okay, there's 2 more that we need it to guess. We'll go back to the calc menu, tell it we want a 0. And this one, let's see, this is 1, 2, 3, 4. looks like it's somewhere between 4 and 5. So this time I'll just give it a left bound of 4 and a right bound of 5. Guess, enter. And it comes back with 4.159 if I round it to 3 decimal places. And then this one, for a left bound, remember you can type in a number or you can use the arrow buttons to move to a point on the graph. But either way, you've got to find an x that's a little bit less than the exact x-intercept that you're looking for, and then one that's a little bit to the right or a little bit bigger than the one you're looking for. So this time the one it came up with was 5.7296, about 5.730. So that's how you would do it using a graphing calculator, like a TI-84. Now let's do it using the Desmos graphing calculator, and this is the online version. So I went to desmos.com/calculator, and I'm going to type in y equals 2 times the tangent of 2x plus 4. So there's the graph. And this makes it really easy because it marked the x-intercepts, and all I have to do is point to one with my mouse, and this one has an x-coordinate of about 1.017. Then here's one with an x-coordinate of about 2.588, 4.159, and 5.73. And there are more, but they're outside the interval we're looking for. So we found the 4 that are between 0 and 2 pi. The other example we had was x squared times the sine of x equals 1. Now, before we go putting anything into the graphing calculator, let's rearrange this a little so that there's a 0 on one side. Because we want a 0 on one side so that what's on the other side is a function that we're finding zeros for. We're finding x-intercepts on the graph of that function. So here that's going to be x squared times sine x minus 1 equals 0. We're looking for x's that make x squared times the sine of x minus 1 come out to equal 0. So let me go to Desmos and put in y equals x squared times the sine of x minus 1. There's what the graph looks like. And it looks like we have an x-intercept here at about 1.068 and one here at about 3.033. And then there's one here at 6.308. Is that past 2 pi? I wonder what 2 pi is. You know what I can do? I can change the scale on the x-axis so that the step value is pi or pi over 2 or anything like that. I'm just going to make it pi. So I typed in pi. And now, let me zoom in a little here. Okay, it looks like we're just a little bit past 2 pi when we cross the y-axis. So that one wouldn't count, just the two that are between 0 and 2 pi.